All right, one last example for us to go through. I had started shooting this example and then my recording device, aka my phone, kind of glitched out on me. So that's why you see a little bit written here, but I'll go over that again. This is going to be an IVP. I figured it would be a good idea to squeeze an IVP in there since we haven't done one of those yet. So to start us off, first of all, notice that this DE involves a hyperbolic function, cosh of x. We haven't seen any of those occur yet in our examples that we've done so far, but it's good to kind of encounter one of those. The auxiliary equation for this one's a very simple one, m squared minus 1 equals 0. That's easy to solve. That leads us to this complementary solution. Now, looking at this complementary solution, remember what we're supposed to be doing is we're supposed to be checking what we would expect our yp to be against the terms that are appearing here. Now, you would expect yp to look like this. A cosh of x plus b sinh of x. And the reason for that is because this appears initially like a case 1 situation. And in a case 1 situation, what you would do is observe all possible derivatives of this guy. Remember, cosh of x, its derivative is sinh of x. Derivative of sinh is cosh, and they just bounce back and forth. So we need a linear combination of those. Linear combination of cosh and sinh. Initially looking at these, it appears as though there's no overlap between yp and yc. But you would be wrong if you said that because you're forgetting how these functions are defined. Remember, we'll just say cosh, for example. I'm going to write this up here. Cosh is equal to 1/2 times e to the x plus e to the negative x, right? Now, that e to the x and that e to the negative x, oops, I was off the screen. That e to the x and that e to the negative x make an appearance here. So, for example, if I were to, say, pull a 1/2 e to the x out of this guy and a 1/2 e to the x out of this guy so that I have something like this. C1 minus 1/2 e to the x plus C2 minus 1/2 e to the negative x plus 1/2 e to the x plus 1/2 e to the negative x. Just kind of doing something like that. These two terms combine to give me that cosh of x. So basically what this is saying, in fact, I probably could have done that in a much simpler way if I just noticed that if I choose C1 and C2 to both equal 1/2, then this thing becomes cosh of x, right? So cosh is included, as is sinh. If I let C1 equal 1/2 and C2 equal negative 1/2, both of those functions are included amongst my complementary solutions. So no, I can't just use them as is. I need to multiply them by x. That's why I left that little bit of space there. Okay, now we're going to find our derivatives. And again, both of these will require the product rule. For brevity, I'm going to jump straight to what the simplified expressions would look like. So the derivative of this is going to end up looking like bx plus a cosh of x plus ax plus b sinh of x. Verify that. Make sure I did that right. I did, but still make sure. Yp double prime, what's that equal to? Well, that one, after simplifying, is going to look like ax plus 2b cosh of x plus bx plus 2a sinh of x. Okay? Again, skipping a bunch of steps there, but you should be able to fill in those gaps. Let's take what we have now, put it into our original DE, and then see if we can work out those coefficients. So it's supposed to look like y double prime minus y. I'm going to use this expression, ax plus 2b cosh of x plus bx plus 2a sinh of x, subtract yp. That's what my DE is telling me to do. So minus ax cosh of x minus bx sinh of x, and that whole thing should come out to cosh of x. Okay, let's combine some stuff here. So I have an ax cosh of x and a minus ax cosh of x. Those ax's are going to cancel. That's going to leave me with 2b cosh of x. Similar thing is going to happen here. I'm going to end up with plus 2a sinh of x equals cosh of x. Okay, now we just equate coefficients. So 2b should equal 1. That's the coefficient that I have on this guy. 2a should equal 0, which means that a equals 0 and b equals 1/2. Okay, so that means my general solution should look like my complementary solution, C1 e to the x plus C2 e to the negative x. A was equal to 0, so I'm going to lose that term. B was equal to 1/2, so that's going to be plus 1/2 x sinh of x. Now, we're not done because, again, remember, this is an IVP. We have initial conditions, right? So we have this, y of 0 equals 2, and y prime of 0 equals 12. That's what our initial conditions were. In order to use these, notice I need to know what y prime looks like. So I should differentiate my general solution, which will give me c1 e to the x minus c2 e to the negative x. And then this guy I need the product rule for, so I'm going to have 1/2 sinh of x plus 1/2 x cosh of x. Okay? Now, we're going to substitute, we're going to plug in 0 for y up here. If I plug 0 in for, 0 in for x up here, so that's going to give me c1 plus c2, then plugging a 0 in here, that whole term goes to 0. So I get c1 plus c2 equals 2. Here, y prime of 0, again, I'm going to end up with c1 minus c2. Now, sinh of 0 is 0. You can plug that into, the sinh function using the exponential definition for that. It's equal to 0, so that term's going to go to 0. And then cosh of 0 is not equal to 0, but since I'm plugging a 0 in for x here, that term also goes to 0. So those terms drop out. This is equal to 12. System of equations. You've seen that I don't use the time to solve those because those are straightforward. We end up with c1 equals 7, c2 equals -5. So my solution, after plugging in these parameters in my general solution up here, should look like 7 e to the x plus, minus 5 e to the negative x plus 1/2 x sinh of x. Now, you can leave it that way. That's fine. That's a totally valid solution. But since we're already using hyperbolic functions, and I'm seeing e to the x's and e to the negative x's floating around out here, notice that one thing I could do is I could do this. I could borrow 5 e to the x's from this. So that's going to be 2 e to the x plus 5 e to the x minus 5 e to the negative x plus 1/2 x sinh of x. If I factor a 10 out of this, not a 5, but a 10, I get this. 2 e to the x plus 10 1/2 e to the x minus 1/2 e to the negative x plus 1/2 x sinh of x. Everything in the parentheses there is equal to sinh of x. So I could write this. Y equals 2 e to the x plus 10 sinh of x plus 1/2 x sinh of x. You technically don't have to do that. Again, this may not even seem much simpler than this, But because we're already looking at things that are given in terms of hyperbolic functions, it kind of makes sense to get as much use out of those hyperbolic functions as possible. Okay, that's our only IVP that we look at in this section, and that's going to wrap up 4.4 for us.